Hey friends, so here we are back in section 8.6, and you know that we are going to talk about the law of cosines now. So let's go ahead and take a moment and let's remember what that is. And if you remember, the law of cosines was kind of weird because if your a squared is equal to b squared plus c squared, right? Minus 2bc times the cosine of angle A. And what I talked about in the last video to kind of help us remember what how to orient this particular equation, because like there's a bunch of different versions of it, is to remember that if you are focusing on side a squared, you'll be talking about angle A. It'll look like the Pythagorean theorem at first, but then it can't be because it's a right angle. You got to subtract some off, and that's going to be 2b times c times cosine A. And so in this case, we are not looking for, well, let's see, we're looking for side x, which is across from c, and basically we can change this, right, in any way. And what that means is, so if I'm looking for side c, the formula is, let me write it in black, the formula would be c squared is equal to a squared plus b squared, very much like the Pythagorean theorem, minus 2ab, notice that we're using the same letters here, times the cosine of angle C. And so that's how we're gonna use this to get to what we want. So notice the situation where we use this when we have a side angle side situation where we've got one side and one angle and another side of that triangle. You want to pull out the law of cosines. So how are we going to use this? Well, we're going to just pretty much do some substitution and solve for what we're looking for. So let's see how this works out. So I'm rewriting the formula, and now I'm going to start substituting in. So C, the length of side C is x squared. That's what we're looking for. A squared is going to be 9. B, or 9 squared. B squared is going to be 11 squared minus 2 times 9 times 11 times the cosine of 28. And just like we do anytime we're dealing with a trigonometric function or a trig function, what we're going to do is we're going to try to do as much work as possible on the front end so that it's calculator ready. And so x squared is equal to 9 squared plus 11 squared. All of this stuff here looks good to me. I really want to know what x is equal to, so I might just take the square root of all this stuff. So 81 plus 121, which is 11 squared, minus 9 times 11 is 99. When I multiply that by 2, I get 198 times the cosine of 28. I think I'm just being extra. I could have plugged all this in a calculator. Let's go to Desmos and see what we get. So here I am in Desmos, and I just literally put in square root of all of this stuff, did the things that I needed to do, plugging it in, and I got 5.21 is the length of that side. And so x is equal to approximately 5.21. They didn't give us the units, so I'll just put it like that. And then I asked myself, does it make sense for this little angle to have a length of 5 across from that little angle, for the side length to be 5.21, where the other side lengths are 11 and 9? For me, that feels right, so I'm feeling confident. So I feel like we did a good job. Remember, always check to make sure that the answer you get is sound. And I did make sure, by the way, I didn't say this before, but I did make sure that my calculator was in degrees, so I feel confident about what I got. Let's take a look at this one. Here's another opportunity for us to use law of sines, and that's when we have side, side, side. So if we're given 3 sides and we need to find an angle, we could use law of sines. Let's see how it works. I'm just going to write down a squared is equal to b squared plus c squared minus 2 times bc times the cosine of angle A. And I'm just going to treat this side as if it's angle A and this side as A, and let's call this B and this C just to work it out. So now A, side A, 8 squared is equal to these other two sides, 6 squared plus 3 squared minus 2 times the quantity of 6 times 3, you see what we're doing here, times the cosine of this angle. I'll say angle X because that's what we're looking for. And now what I'm going to do is I'm going to do some math magic where I'm going to work it out so that I can solve for the cosine of X. I want to get the cosine of x by itself. Because if I figure out what the cosine of x is, remember I can do inverse cosine. I know you're tapping your temple thinking, yeah, she's got some good stuff going on there. Thank you very much. So watch what happens. So I'm going to first subtract all this stuff and get myself together. So this is, let me write this out. 64 is equal to 36 plus 9 minus 2 times 6 times 3. That's 18 times 2, which is 36 times the cosine of x. And if I simplify further, I get that 36 plus 9 is going to give me 45 minus 36 cosine of x. If I subtract 45 from both sides, remember my goal is to isolate that cosine term. So if I subtract 45 from both sides, what I get over here is 19, if I'm not mistaken. I get a 19, a positive 19 is equal to negative 36 cosine of x. Now I'm going to divide both sides by negative 36, and I get 19 over negative 36 is equal to cosine of x. And so now I'm going to take this information and I'm going to do what I learned in a couple sections before where we did inverse functions. If this is the case and I want to solve for x, I say inverse cosine of 19 over negative 36 is equal to x. So now I'm going to use Desmos to get that value. Inverse cosine could be done by doing cosine and then doing the exponent of negative 1. And then now I've got the inverse cosine function. What was it? Negative 19 over 36, right? And then I get 121 degrees and 121.8 degrees, and so I'm going to put that down, round it to the nearest degree, 122 degrees. So let x is equal to 122 degrees approximately. Let's make our wavy lines. And notice this is a pretty big angle, and it's across from the side that is the greatest. Seems reasonable that this large angle, this large obtuse angle could be 122 degrees. All right, this is some complicated stuff, but you guys are doing very well. Let's keep it moving with this real world example. So this example is one of those examples where they give us a handy dandy picture, but we need to utilize our information to fill it out, to get the triangle, to get the information we need to do. So Drew and Hunter are playing basketball, and Drew passes the ball to Hunter, and then when he is 26 feet from the goal. When Drew passes the ball to Hunter, Drew is 26 feet from the goal. That's what I understand from that statement. So from here to here is, let's write a thinner pen, 26 feet. Can y'all see that? Hopefully so. So that's 26 feet from the goal and 24 feet from Hunter. So the distance from here to here is 24 feet and 24 feet from Hunter. How far is Hunter from the goal? How far is Hunter from the goal? This is what we're looking for, x from the goal to, how far is Hunter from the goal if the angle from the goal to Drew to Hunter is, from the goal to Drew to Hunter is 34. Ooh, we had to work there, but here's the triangle that we're looking at. I'm going to redraw it over here just so it's a little bit less crazy looking. So we have 24 feet here, 26 feet here, and we're given that this angle is 34 degrees. And we need to find this. This length would be Hunter to the goal, okay? So we see that we've got side, angle, side. And this is a great opportunity to do law of sines. And so law of sines tells me, I'm just going to write this one, a squared rather is equal to b squared plus c squared minus 2 times bc times the cosine of, I don't know why I can't write cosine, my chablitos, but oh, I see what I did wrong, of angle A. I think it was the extra c that threw me off. You guys get what I'm doing here? So a squared is equal to b squared plus c squared minus 2bc times the cosine of A. So let's orient ourselves. So this is A, and this is side A, and this is angle A. So x squared is equal to 26 squared plus 24 squared minus 2 times 26 times 24 times, I'm sorry, cosine of, let's move this triangle away. You guys are so patient. I appreciate you. Times the cosine of 34 degrees. And right now, I'm going to be honest with you. I am about to shove most of this into Desmos and let them do the math for me. So x is equal to the square root of all of this. And I'm not even going to bother doing any of the math. I'm going to let the calculator do it for me. 26, so the square root of 26 squared plus 24 squared minus the quantity of all of this stuff. Parentheses will be our friends when we plug this into the calculator. And I will show you how easy it can be. Let's do it. And so here it is, all just shoved into the calculator, and we got a nice answer of 14.7. So it seems that Hunter is 14.7 feet away from the goal. And here we have this last one, solve a triangle. And remember, when we solve a triangle, we find out all the information about their angles. So solve the triangle ABC round to the nearest degree. Here we have three sides that were given. Obviously, when you got these three sides, you couldn't use law of sine. So this is a law of cosine situation. Repeating the law of cosines, a squared is equal to b squared plus c squared minus 2 times a, nope, not just kidding, minus 2bc times the cosine of a. I like to start off with our law. So now, let's say I'm looking for this angle, because if I find this angle, then maybe I can do some cool stuff. So if I find this angle, angle A, then the opposite of angle A is side A, which is 15 squared, and I'll call this 13 squared. Oh no, let me use the right ones. 12 squared plus 13 squared minus 2 times 12 times 13 times the cosine of A, which is what I'm looking for. I'm going to solve for cosine of A. Watch how we just use our algebraic abilities. So 12 squared has to be subtracted from both sides. 13 squared has to be subtracted from both sides. Then I'm left with negative 2 times all of this jazz, right? And then the final thing I need to do, because I want to isolate the cosine A, is I'm going to divide by all of this stuff here. So look at what I did. I moved everything over to one side, then I divided by this stuff, so I've isolated cosine of A. But we need to know what cosine of A is. We need to know what A is. So we know that when we're given a ratio and we're looking for the angle, we've got to do the inverse cosine of whatever that ratio is, even if it's an ugly big junky thing like this. So we get the cosine inverse of this thing. That's what A is going to equal, and I'm going to go and find that out by using my handy dandy calculator here. And so there it is. I took my time and I carefully put it into Desmos, checking back and forth a few times, making sure I wrote everything in correctly, and I get 73.6 degrees is the angle that we were looking for. That's angle A. So angle A is, now I just forgot it as I said it, 73.6 degrees. So let me put that down here. So that's 73, let's do it that way, 73.6, and now I've got more work to do. So I have to find B, and I've got to find C, and I've got to go through and find all the rest of these angles. But you know what I'm feeling good about? I'm feeling good because I don't have to do this thing again. I could use law of sines. Remember law of sines from back in the day? Remember, guys? Sine of A over A is equal to sine of B over B is equal to sine of C over C. We now have the power to do that because we've got an angle and a side pair. So I can rock this. Sine of 73.6, all of that over 15 is equal to, now I can find any angle I want. Let's find angle B is equal to the sine of B over 12. You know what we're going to do? We're going to make this calculator ready. And so what I'll do, I isolate sine of B and I get this. And then to solve for angle B, I need to use the inverse sine. I'm going straight to Desmos and I'm going to calculate that. So now I get 50 0.12 degrees for that angle. Let's call that 50.1 degrees, and guess what? I can use simple mathematics to add up and figure out C, because C is just going to be 180 minus the two other angles. That subtraction gives me 56.3 as my final answer. Let's talk later. I hope this was good. Take care.